Key algorithms. Machine learning uses a variety of algorithms, each with its own strengths, weaknesses, and ideal use cases. Understanding how these key algorithms work will help you choose the right tools for your projects and build models effectively. In this section, we will explain five fundamental algorithms that form the foundation of many machine learning applications. Linear regression. Type supervised learning. Linear regression is one of the simplest and most widely used algorithms in machine learning. It models the relationship between the dependent variable, that is the target, and one or more independent variables, the inputs, by fitting a straight line to the data. How it works? It finds the best fitting line through data points by minimizing the distance between the line and the actual data values. The line has an equation of the form y is equal to mx plus by is equal to mx plus b, where y is the predicted value, x is the input variable, m is the slope, and b is the intercept. Example use cases: predicting house prices based on the features like size, location, and number of rooms, estimating sales figures based on the advertising spending. Linear regression is a good starting point for regression problems because it's simple, interpretable, and efficient for small, moderately sized data sets. Decision trees and type is supervised learning, classification, and regression. Decision trees are versatile algorithms that split data into branches based on the decision rules. They make predictions by following series yes or no questions leading to a final output. How it works? The algorithm identifies the feature and threshold that best splits the data to separate different classes or minimize prediction error. It repeats this process, creating branches until it reaches a stopping condition such as maximum depth or minimum samples in a node. Example use cases: classifying whether an email is spam or not, predicting whether a customer will churn based on the behavior pattern, assessing loan approval based on an applicant characteristics. Decision trees are easy to understand and visualize, making them popular for explaining model decisions. However, they can overfit the data if not properly controlled. K means clustering and type is unsupervised learning, that is clustering. K means is popular algorithm for diving data into groups or clusters based on similarity. Unlike supervised learning, K means works without labeled data. How it works? Choose the number of clusters kk. Randomly place KK cluster centers, also called as centroids, in the data space. Assign each data point to the nearest centroid. Update centroid based on the mean position of points in each cluster. Repeat the assignment and update steps until centroids stop moving significantly. Example use cases: customer segmentation based on buying behavior, grouping similar documents or articles, detecting patterns in large datasets for exploratory analysis. K means is efficient and works well for finding natural groupings in data, but it assumes clusters are spherical and similar in size, which might not always be true. Next is support vector machines, SVM. Type is supervised learning, classification, sometimes regression. Support vector machines are powerful algorithms used primarily for classification tasks. They work by finding the optimal boundary, that is called hyperplane, that separates data into different classes. How it works? The algorithm looks for the hyperplane that maximizes the margin between classes. Only the data points closest to the hyperplane, called support vectors, determine its position. SVMs can handle nonlinear boundaries using a technique called kernel trick, which transforms data into higher dimensions where separation is possible. Example use cases: classifying text documents as positive or negative sentiment, identifying handwritten digits, detecting fraudulent transactions. SVMs are effective in high dimensional spaces and work well when the number of features exceeds the number of samples. However, they can be computationally intensive for large data sets. The next one is Naive Bayes. Type is supervised learning, classification. Naive Bayes is a family of simple yet effective classification algorithm based on Bayes' theorem and the assumption that features are independent of each other. Despite its simplicity, Naive Bayes performs surprisingly well in many real-world applications. Let's see how it works. It calculates the probability of each class given the input features, chooses the class within the highest probability as the prediction, assumes independence between features which simplifies calculations. Example use cases are spam detection in emails, sentiment analysis in text, classifying new articles into topics. Neobase is fast, efficient, and requires relatively small amount of training data. It's especially useful for text classification tasks. Practical relevance. Understanding these key algorithms provides several benefits, helps you choose the right model for your problem, enables you to explain how your model works to others, builds a strong foundation for learning more advanced techniques. In the upcoming video, we will explore how to implement these algorithms using Python and real data sets, giving you practical experience in building machine learning solutions. Let's continue deepening your knowledge of machine learning.